Sir, shall we start the session?
Okay, sir. Okay, sir. Go ahead.
Okay, sir. Thank you. Good afternoon, participants. Today we are here, and this is the last and final session in this FDP. So today we are going to understand and learn about artificial neural networks, right? A class of machine learning algorithms, right? A specific kind of machine learning algorithm which stands as a separate algorithm, right, in this list of machine learning algorithms, because the way the data gets structured, the way the data flow will flow in the architecture is different from the data that that is actually passes through the existing other machine learning algorithms, right? So before we start off the artificial neural network, first we need to understand how the biological neural network is present in the human brain, and what is the functionality of the neuron, right? And how the signal electrical signal passes from one neuron to other neuron, uh, and how the processing happens in the neural network in the human brain. We need to understand first, and then we proceed to artificial neural network. Fine. So then moving on, these are the points that we will cover in today's session. So first we talk about biological neural network, then we introduce ourselves to artificial neural network and its architectures, right? Then we will go to activation and loss function, and their importance, and we see a specific type of a neuron called a perceptron, and how these perceptrons are layered to form a multi-layer perceptron model, and what is the significance of that multi-layer perceptron in updating the parameters of the artificial neural network. And what is actually a parameter in artificial neural network, we will come to know when we see that. And then we will also understand some mechanical engineering scenarios specific to this perceptron, right, and artificial neural network in particular, right? So, and then we'll wind up the session. We'll also see some demonstrations, right? So coming to this biological neural network. So in the slide you are seeing to the left and the right, both are actually the arrangement of neurons in the brain, right? In the brain we have millions of neurons, 10 to the power value, right? We have those many number of neurons in the human brain, and these set of neurons, or these neurons, let us say, will not connect, all neurons will not connect at a time, right? So those specific neurons uh, which are uh, which are actually participating in the what you say in the signal analysis process will only be connected while other neurons will work for other activities, right? Maybe they may work for other activities, or some of the neurons may be silent also, right? They may be inactive also. So we never know what neurons are actually active and what are actually silent, right? So we just imagine that these are the set of neurons which are actually connected, and they are responsible for generating a output signal, which we actually represent in the form of expressions. Human beings, we represent in the form of expressions, right? So if you go to the internals of the biological neural network, so if you see to the left, in the bottom of the slide to the left, you are seeing a single neuron that has so many, what you say, the represent the components, right? So this neuron contains soma, dendrites, axon, axon terminals, and synaptic junction, right? So what are all these? So coming to the first one, dendrite. Dendrites actually, they are they are the components that receive signal from other neurons, right? If you see, the neurons are actually connected in this manner. To the right side of this presentation, you are able to see how the neurons are actually connected, right? Only two neurons are shown in this slide. You can just imagine how millions of neurons are connected in this fashion, right? Now, so dendrites actually receive signals from other neurons, uh, and those signals will be treated as input to this current neuron. The signals that are received from the other neuron are the output signals, and those output signals are given as input to the current neuron as input or input signal, right? These inputs from all the dendrites, from all sides, are forwarded to the soma, the location called soma, where these signals are actually processed, right? So the processed signal, which we say as a output, will propagate in the forward direction towards axon terminals with the help of axon, right? Axon is a long connection in between the neuron and the what is a synaptic junctions and axon terminals, which carry the output signal from the current neuron to the other neuron towards the other neurons, right? So there what will actually happen is the signal efficiency will get optimized. So in the sense, if at all a certain threshold, beyond certain threshold, uh, if the value is obtained from the what you say soma, after processing the signal, if you can quantify that signal, and that signal quantified value, if it is beyond certain threshold, right? So then what happens is, this particular signal will actually be active and will get forwarded to the synaptic junction. As you are seeing into the right side, the electric signal will come to the synaptic junction, where the other neurons will get connected with the synaptic junction. Through synaptic junction only, the output of the current neuron moves to the dendrites, onto the dendrites of the other neuron, right? So at the synaptic junction, you are able to see the axon terminals. So these axon terminals will connect the axon as well as the dendrites, right? In this junction, right? Now, so like this, the signal will actually pass on from one neuron to other neuron, right? So like this, what happens is, in the set of billions of neurons in the human brain, only few signals, few neurons will get actually connected, will get wired. Strictly speaking, they will get wired, and this electric signal will propagate to the what you say, uh, the one of the five sense organs, and that sense organ will respond with that in the form of an expression for that signal, right? So you see here, uh, we'll see what are as I told you, these are the definitions. So dendrite is a location where the signals from the other neurons will be received, right? And in the at the current neuron, and synapse is a point where the connection is present with other neurons, right? So that's why we say synaptic junction, and we also say the junction, the synaptic weight, right? Because with how much strength the connection is, the junction, the connected junction is present, that is the most important thing, right? So if the synaptic weight is high, then the neurons are actually strongly connected. If the synaptic weight is less, so the neuron connection is not that has that strength, but still they are connected in some sense. Only what you say, signal will be incompletely passed on to the next neuron, right? So then we have soma is a location of the in the neuron where the signals will get processed. So is any doubts?
No, sir, you continue, sir.
Okay, and then we have axon, and axon is, as we have seen from the previous slide, axon is a long tail that carries the processed signal from soma to the other neurons, right? So you see, this is the actual arrangement in the brain, how the neurons will actually be arranged, right, in the brain. So this is understood as a massively parallel interconnected network of neurons, right? So now you see, at the end of this, at the start of this network, strictly speaking, at the start of this network, so you the inputs are received from the sense organs, and these inputs are taken from by the dendrites, right, at the end of the sense organ connection to the neuron. So there the dendrites receive the information from the sense organs, and only few neurons will actually be connected. So in like this, if you see, before understanding this, if you see how only few set of neurons, as you observe here, these are the neurons are actually responding, right, for the given input. And here also only few neurons are actually getting responded, not all neurons are actually responded, you see. And also it might be the case where these set of neurons will actually be working for some other activity, right? So if I simply give the example, when you are watching television, if a mosquito bites you, so still what you do, you have the sense that mosquito is biting you, immediately you will respond to either to what you say, kill that mosquito or make the mosquito move away from you, right? So that means few neurons are actually working for that activity, right? And some other set of neurons are actually processing the visual information that that you are receiving continuously from the from your smartphone or from the external environment or surroundings, right? And few other neurons are actually receiving information from the ear, and they are actually what you say, either they are forwarded to the brain, or they are ignored based on the contextual importance that you actually, that your brain sets actually, right? So here these neurons actually they respond in this fashion, and they are arranged in the form of hierarchy, right? As you are seeing, these three neurons, they actually are connected to a single neuron in the upper level, right? From the current level, when you are moving to the upper level, these three are connected to the single neuron, and this single neuron is responsible to take the outputs from these three neurons, process here, and forward the result either to the sense organ, right? Or if it is required to store something, it will send forward those electrical signals to the brain to get stored, right? So here is a interesting point. If the if I see something funny from, and hear something funny from the what you say visual screen, from the visual screen, now what happens, what is actually happening here? If you see carefully, uh, one particular neuron will fire if visual information is funny, right? Other particular neuron will get fired if speech style is funny, right? And the third particular neuron will be fired if text is funny. So what is meant by the firing of this neuron? So we just go back and see, this is this particular image. In this particular image, you see action potential, right? This action potential will, what it does it optimizes the output. What is meant by optimizing the output? Either to make that signal active, or to make that signal nullify, zero, make that signal zero, right? Either to enable the signal or to disable the signal, right? So firing is nothing but the neuron firing is nothing but here the neuron is set to enable state. So that is the meaning of the firing of a neuron, right? So this neuron is active based on the output condition on this action potential, right? So we will see in the form of a particular condition while we understand artificial neural network. So if this action potential has reached beyond a certain threshold value, then this neuron is said to be active. The output of the neuron will now get propagated to the next neuron. If this action potential value is less than certain threshold, then this neuron is off, this neuron is not active, right? This will be disabled. So what happens, the output will now not get propagated or gets forwarded to the next neuron. So did you understand the point, participants? If you have any doubts, please respond. Are understanding this point? So because if you understand this, only
Yes,
then,
sir.
okay, fine, only then it is possible to understand the mapped artificial neural network concepts, right? Fine, fine. Then we'll move forward. And now if you see, this neuron is only fired if two out of these three neurons are actually fired, right? The upper level neuron will only be fired if either two out of three neurons will be fired. So this is the threshold. The threshold condition set is, if two out of three neurons are fired for this upper neuron, only then this neuron will be enabled and the output is generated. So what is the output that you are seeing from the human end? So the person is falling, he is falling on the floor and he is simply laughing like anything, right? Because some, let us say, some joke has been shown in the television. So he is responding to that joke in the form of this rolling out by falling on the floor, laughing like anything, right? So, and this all these things, all the processing of this entire input will happen within no time in our brain. That is the what you say, the interesting aspect for the human brain, right? It is the interesting aspect for the human brain. So within no time, the humans respond to the input in the form of the expressions on the face or in the form of gestures in the body, right? So that is the, what you say, the positive thing, and the what you say, the highest uh, specificness as provided by the god to the human beings, right? So this kind of response is what you say, we are feeling the input, and we are processing the input, we are taking the input, we are processing the input, and we are responding to that input, right, in the form of output within no time, right? And also, if you understand this point, humans, when you see something through the eyes, actually at the end of the eye, what happens is the image will get upside down. So whatever you see in the front, like I am seeing the camera from my end, this camera, when it enters into my eye, and when it enters to the end of the eye, what happens is the what you say, the label that is present on the camera and the entire camera will be felt upside down. Now that upside down information will get traveled to the brain, where brain is actually divided into multiple regions called faculties, right? So each and every faculty is responsible to process the information coming from different senses, right? So uh, one part of the one faculty in the brain is responsible to take this upside down image received from the eye, and transform it to the original form, right? As you see, uh, as you observe the environment with your eye, and everything seems normal. This is because of that particular faculty present in sitting in the brain and processing that particular image, right? And all this thing is happening within no time, just at the blink of the eye. You are able to observe and say that everything is normal, right? thanks to the what you say, the person who is invisible in this entire globe and who is actually helping us to do this, right? So this is not a what you say subjective aspect of discussion, but we are simply understanding and realizing this aspect, right? Now fine, now we are moving from here, and we are now just after understanding this point, we are able to now what you say get motivated and we are now ready to understand and develop a artificial neuron, right? And if we arrange those neurons in a particular fashion, we are able to generate what is called as artificial neural network, right? So then what is artificial neural network? As you have seen biological neural network in the previous slides, like this, we also have what is called as artificial neural network. So what is artificial neural network? It is a computational model inspired by the brain, right? It is inspired by the brain, and it is composed of large number of interconnected processing nodes. So in the definition itself, the actual concept of deep neural network is present in the sentence, right? Large number of interconnected processing nodes. So we today we the world is saying that I have developed, or I have used a deep neural network to process something, to come to generate an inference, to come up with an inference, right? But that thing is already present at the in the definition itself for the artificial neural network. So that's why any deep neural network in the forward direction to see the output is treated as a artificial neural network, right? It is artificial neural network actually, basically, right? That artificial neural network based because of certain requirements and certain what you say needs, we are saying that as a deep neural network, right? Why we say that is deep neural network, we will come to know at the end of this discussion, right? Now, so ANNs are used to predict and recognize patterns and make decisions, right? Fine. Now, so the brief history of ANN, if you see, it all started in 1940s, right? And that is an electronic brain. The name given to this is electronic brain, which is a machine, electrical machine. It has been developed on the basis of logic circuits, like as you see here. Electrical circuit has been devised. They have developed, and what it does is uh, weights are actually weights are nothing but the parameters in the ANN. Please try to understand. As we know in supervised learning, we talked about parameters. So model parameters are nothing but weights here, right? So these weights are actually not modified by this model. What is the model specified with McCullough? It is a neuron that is responsible to process the incoming input from other neurons and generate the output, right? And generate the output. We will see what is that particular signal that this is known as activation function. So we will come to know about that activation function. And what is the advantage of this particular electronic brain? It has adjustable weights and weight, but weights cannot be learned. What is meant by adjustable weights? You can modify the weights in the forward direction, right? You can change the weights before the inputs and weights are actually getting processed, but those cannot be learned, those cannot be changed once you observe the what you say linear boundary, or once you observe the decision boundary, and if the decision boundary misclassifying the given input, you cannot modify the weights because of this model. So this model has been improved by this Rosenblatt and Widerhoff, and what they have said is it is possible to modify the or change the weights. It is possible to change the weights, right? They have developed what is called as a weight update rule, and that weight update rule modifies the weights accordingly, right? And they have defined what is called as threshold upon weights, right? These weights with the input, they pass through this threshold, and that threshold, if that threshold is passed, it means that particular input signal is changed to the output signal, right? So as you see, this neural network, artificial neural network, can be used as both supervised learning algorithm as well as unsupervised learning algorithm based on the uh, neurons that they are connected in a particular form, right? So I will show you the image within few minutes, how many different types of networks are there and how those networks got classified into supervised and unsupervised neural networks. We'll come to know within a few minutes, right? Then we see a particular network that is developed by Minsky and Papert, so which has solved the problem of XOR. So if I use this particular perceptron, so this Rosenblatt has Vittroff have developed, they have modified this Mikalapat's new Pitts neuron, and they have developed what is called as perceptron. So this perceptron is not in a, is not cannot it cannot classify the XOR outputs. So what is the what is the output of XOR gate for two input XOR gate? What are the outputs that we have? For 0 0 it is 0, right? For 1 0 it is 1, for 0 1 it is 1, and for 1 1 it is again 0, right? If you plot those what you say points on the xy plane, right? So the points are plotted in this fashion, right? So and so you see, this should be white, actually the point should be white. Sorry, this is what output. If you see, this is what output. What is this output, right? Anyone please tell me, what is this output? And gate output, right? It is AND gate output, 3 zeros and single one, right? So this is AND gate output, and here perceptron is able to learn a decision boundary that in the linear fashion that clearly separates both the positive and negative examples, right? So this is a single positive example, and all the three remaining are negative examples. So the class labels are nothing but ones and zeros for the gates, right? So 1 represents positive example, 0 represents negative example. So AND gate and OR gate can be clearly classified. So the examples can be linearly separated. But for XOR gate, it is not possible to separate linearly. So see here, this is the output of the XOR gate. If I simply draw a line here, straight line, what happened? One positive example has been misclassified. But if I draw a line here, once again, what happened? A positive example has got misclassified. So for XOR problem, for XOR gate, what happens is your perceptron uh, shows up problems in classifying the examples linearly. So what these people, they have come up with what is called as an idea of what you say, creating a solution where these two positive examples can be grouped as one unit, and these two negative examples can be grouped as one unit, and these two positive examples can be grouped as other unit, right? This XR problem is realized with the help of what is called as multi-layered perceptron model, and in that model what they have done is they have implemented, these people have implemented what is called as concept of back propagation. Here you see, what is back propagation? Forwarding the or forwarding back the error, making the error. You have calculated error at the output layer, right? In this output layer you have calculated the error. What is error? Error is nothing but the target output minus the calculated output. What is the calculated output? Right, the calculated output is from the neural network, artificial neural network, right? But the actual output is from the gate, right? So these the difference between the gate output, the output from the gate table, and the output that is generated by this neural network is specified as the error, and that error is back propagated to the previous layers where the weights are present in order to adjust those weights in such a way that the output that is obtained at the output layer will be less, will be as less as possible, right? So solution to a non-linearly separable problem is specified with the help of backpropagation network, which is this one. This is a non-linearly separable problem, right? So from there, they have used this backpropagation network successfully for the concept of autonomous cars, right? And they have come up with various what is say solutions by using this backpropagation. They have tested. So if you have any doubts with respect to this discussion, you can download the Tom Mitchell textbook and you can see the chapter of artificial neural network, in which this particular backpropagation network they have used for the for sensing the continuously taking decision on the continuously mounted inputs from the camera, right? While the car is moving in the on the highways, right? So then over a period of time, this artificial neural network, the basic fundamentals of artificial network is still used to form a new classifier called SVM, right? And this SVM works on the concept of hyperplanes, and these hyperplanes are responsible to clearly separate the positive examples and the negative examples, and any examples that are on this plane that is shown here, those are said to be support vectors, and these support vectors are crucial in determining the accuracy of the classifier, right? And further, if you move, today we are actually seeing the success of this deep neural network. The concept of this more number of hidden layers in the deep in the artificial neural network is not new, which was actually proposed in the time of 1980s, right? But that was not realized till 2006 or 2010, just because of the computing capabilities, the what you say, the crunch of the computing capabilities. So once the computing capabilities are arised and high performance computing has came into existence, so these concepts are now a realization. This hierarchical feature learning, which is the actual heart of this deep learning, right? Any doubts here? When the test will be conducted, so that we will be looking after the session, right? Already that was answered in the morning session. Fine. Now moving forward, the comparison between BNN and ANN, the stimulus is nothing but the input stimulus to the neuron. Receptors are nothing but the input layer in the ANN. Neural net is nothing but the processing module, that is the artificial neuron, right? And then a processing content that is present in the artificial neuron, and the biological neuron is nothing but the artificial neuron in which the processing happens. And effectors are nothing but the or the let us say the hands, the legs for the human being. And this is the output layer, and a response that that comes out of the biological neural network is the output, right? And the entry to the next neuron, right? So you see synapses, at synapses what happens is weights are actually utilized, and dendrites are nothing but the summing functions. Cell body is nothing but the activation function. Action is nothing but the output, and the threshold value is nothing but the bias. So this bias is different from the bias that we have seen in the supervised learning discussion. So this is actually useful to determine whether the output is positive or zero, or whether the output is whether the output can be enabled or disabled, right? This is the what is a crucial aspect in this ANN, right? If you see in terms of mathematical modeling, so you are providing inputs to the neuron, and these inputs are associated with the synaptic weights, right? And you are calculating the product of the inputs and weights, And when these products of inputs and weights are moving to the neuron, artificial neuron, there the summing of these products of weights, so products of sums, so this is sorry, sum of the products, this is sum of the products. So that is actually happening to the sum of the products. You are adding what is called as bias information, which is nothing but the determining factor whether the output should be neuron should be fired or not. So that is passed to a function which is nothing but activation function, which will determine whether the neuron should be activated or not, right? So the similar kind of network as you see here in the artificial neural network, you are forming a represent you are arranging the neurons in this fashion, right? This input layer is responsible to take the inputs and forward to the hidden layer. This input layer does not do more than that, simply takes the inputs and forwards to the next layer. Then the next layer you are seeing in this image is the hidden layer, which is actually responsible to take these inputs and take the weights that are present on these what you say connections. And it uses each and every neuron in this hidden layer uses these inputs and weights and generates its own output, right? Each and every neuron in the hidden layer is generating its own output. Please try to understand. This is the most important discussion, right? Every hidden neuron is doing its generating its own output, and each neuron, please try to understand, each neuron is composed of two things. The first thing is summation, the second thing is activation, right? Every neuron can be divided into two parts, and each the left part of the neuron, in our discussion, please try to understand, the left side of this particular neuron is responsible to calculate the sum, and the right part of this neuron is responsible to is responsible to activate or deactivate this neuron, right? So let us assume for now that all the neurons are active in the hidden layer, and their outputs are now passed on to the last layer called output layer, and this output layer is responsible to show you the output, right, based on these outputs received from the hidden layer. Right now the so many doubts will arise. uh, does the number of nodes in the output layer will be one every time? That is the first question. How many number of neurons can be there in a hidden layer, right? And how many hidden layers can be formed here? And why this entire thing is called as feed forward network? All these doubts will be there here. I will answer each and every doubt here. The number of nodes in the output layer depends on the type of the problem. So if the problem is to classify the digits, right, input digits, so then how many output nodes will be there in the output layer? 10, right, from 0 to 9. So if you give input as 0, then the node the output node which will show you the output 0 will be activated. Remaining other 9 neurons, output neurons in the output layer, will be deactivated, right? So based on the problem at hand, the number of output nodes will be there, right? Now coming to the next question, how many number of neurons will be there in the hidden layer? So it is a mathematical aspect, so which has got a formula, so which you can actually check it out. And the next thing is, how many such hidden layers can be there? So based on the problem at hand, if you define more number of hidden layers, right, so then it is clear to see the output, and you can see the output with more accuracy if you have more number of hidden layers, right? So these are the answers to the questions. And the next one is, why it is called feed forward network? Because you are moving in the forward direction towards the output, right? Any doubts still here?
No.
Right, fine. We'll now move to the next slide. So you see, these are the what you say significant. These are the strengths of these networks, right? So biological neural network, neuron switching time is 0.001 second, and the number of neurons in the brain are 10 to the power of 10, right? And connections per neuron is 10 to the power of either 4 or 5. and recognition time is 0.1 seconds. So that is the powerful point with respect to biological network. Whereas coming to the artificial neural network, these are the weighted connections and they are highly parallel, and the processing is distributed in nature, and the emphasis is on tuning the weights, adjusting the weights on the in the automated fashion. Right now, so what now, as I told you, this activation function is responsible to either to activate or deactivate that neuron. So now activation functions introduce non-linearities in the network because real world problems are often non-linear, and we generally consider non-linear activation functions to learn complex relationships and patterns, right? We can also define loss functions as per the requirement, but the basic definition holds true here also. The loss function means the difference between predicted output and the actual output, right? And our goal is to reduce this. So this is an optimization criteria which we generally which we have already seen in the supervised learning, and the same kind of optimization criteria holds good here also, and the choice of loss function depends on the type of the problem, right? Now, how many activation functions are there? There are so many list of so many activation functions are there, among which I have shown you few here. Sigmoid activation function, hyperbolic active tangent function, rectified linear unit, leaky ReLU, softmax, right? And loss functions are also many. I have only covered a few things based on the type of the problems, right? You see, for regression you can use mean squared error, which is very popular. For binary classification you use log loss, which is binary cross entropy. For classification, multi-class classification problem, you can use categorical cross entropy, right? We will see in the demo part how do you select this loss function, right? Now, various activation functions and the representations, as you see here. The sigmoid activation function we have seen in the logistic regression, right? The tan h function, it is represented in this fashion, in this curve, right? Half of the S curve is on the positive axis and half of the S curve is in the negative axis, right? ReLU is like this rectified linear unit function, and leaky ReLU is like this, a slight deviation from the for the curve on the that is present on the origin axis, and extreme this is ELU, another activation function, right? Now we can actually plot these activation functions in the tool, right? This is a step function. It's a linear function where you take a step by step, either you take forward step or you will be in the back, you can take backward step, or you will be on the same location, that is 1 or 0, right? And then you have other activation functions as you have seen previously, right? So this is ReLU, the bottom one is ReLU, and this is what you see, this is a tan h, right? And this is a sigmoid activation function, and then this is leaky ReLU, right? And this is once again a sigmoid activation function, right? And sorry, this is not sigmoid, and this is what is called as the what we have seen earlier, it is softmax function, right? So this is softmax function, the last one is softmax function, right? Then now we come to the discussion of perceptron. So perceptron is a specific kind of neuron. It is introduced by Rosenblatt, as you see in the history, and this is a binary classifier. It is used for binary classification tasks, and the activation function that is used by perceptron is step function, right? Now, so this is the way the architecture looks like for perceptron, right? We select the bias value as 1, and if all the if all the weights are considered to be 0, at least the input 1 will be goes to the forward direction in order to activate this particular artificial neuron, right? So 1, if you passes through this activation function, automatically this neuron will be active, right? That is the significance of bias. That is why we are including bias in the architecture, ANN architecture, right? Now, so what is the scenario for this perceptron mechanical engineering scenario? Defect detection in metal components. So how defects are identified? Why? What is the reason to to have defects in the metal components? And what are the aspects? What are the features that are useful to clearly distinguish a metal which is defective or which is not defective in nature? So now, So now if you see, this is the perceptron decision bound. As I told you, perceptron is a linear classifier which will classify the positive examples with the negative examples. So they, you see there is a one point that it got misclassified by the perceptron. So as I told you, it gives you 100% what you say, classification accuracy in some cases, but in real world scenarios the accuracy might fall down like this, right? The precision is 0.96, accuracy is 82, and F1 score is 79%, right? Now, and scenario for a feed forward artificial neural network, as you see, this is feed forward network in this slide. And for that feed forward network, we have another scenario like this, predictive maintenance for industrial machines, right? So some industrial machines might suddenly give a problem by not responding, right? And that dynamic problem can be actually predicted beforehand with the help of artificial neural network. So likely to fail can be obtained, this information can be obtained, so that maintenance can be performed proactively. So there are 10 iterations that has and the important point with respect to ANN is the training time is high. When compared with other machine learning algorithms, the ANN training time is high, and it is required also, right? Because all the neurons should get communicated, and the entire sum should take place, right? Activation should happen. So for all those things, time will take. So that's why, and we pass the inputs, and we calculate in the form of iterations, right? We pass the inputs either one at a time or group of inputs at a time. Accordingly the iterations will occur, right? Right now, before we wind up the sessions, just we see, it is possible to draw engineering figures, basic engineering figures with regression model, and it is also possible to predict the engineering symbols, and you can use what is it, different deep learning techniques for engineering drawing like this, right? So engineering symbols can be predicted, you are seeing on the right side, and through the help of sketch graphs, it is possible to predict the engineering drawing also. So by specifying the constraints on these what you say, un, un, unsolved problem, so unsolved sketches like this, if you pass constraints like dimensions and the rules to this particular unsolved problem, this can be solved by the what is a deep learning network to generate a engineering drawing in this fashion. And there is also interesting point, as you see, it is possible to generate a hand drawn appearance of the CAD, this engineering drawing or CAD model, right? This, all these things are possible with the deep neural network today, right? So now with this discussion, what we do is we simply go to the lab session now. uh, Quickly we will launch the programs, collab. I think they are 1 minute. I will simply download them. Uh, download, download, and download. Fine. Feed forward artificial neural network. I think screen is not visible to all of you. I will now share the screen. 1 minute. So is the screen visible, sir?
Yes, sir. Yes, sir.
Fine.
Yes,
Now,
sir.
okay, thank you. As you see, what we are doing is, in order to work with neural networks, we are using a Keras package, right? We are using Keras package, and this is a Keras package from TensorFlow. So this is a useful package to create artificial neural networks, right? So we from Keras package and from model module, we are importing sequential class. So the sequential class is responsible to create a feed forward artificial neural network, and from layers we are calling what is called as a dense class to say the to form a densely populated hidden layers and in the feed forward direction, right? So so you see what we are doing is we can actually form a model directly like this, right? You, as you're called sequential and you are saying dense, right? What you are doing is you can simply call the sequential constructor, and you can add the layers in the feed forward network, and you can display the summary of that particular network. But now here, if you want to create a user defined network like this, right, the only important thing in a feed forward network is number of hidden layers, right? And you can actually calculate the size of the hidden layer also, right? You see, you are passing the input size and output size and the number of hidden layers and the factor value. And what is this factor value? So this factor value uh, is responsible to form what you say the number of neurons in the hidden layer, right? So what you are doing, you are writing a code in order to append the information with respect to size of the input layers and the output layers, and you are creating these particular layers with the neurons, hidden layers with the neurons, right? And you are printing this hidden layer sizes also here. So now simply we will run this code. So so you'll run this code now. 1 minute, it is allocating RAM and disk. Right, now we'll run this code. So input size is 10, output size is 5, and number of hidden layers are 3. So so with this with this program, the program, what happened? The number of nodes in each hidden layer. How many hidden layers are generated? 3 hidden layers have been generated, right? So you have, as you specified, you should have 3 hidden layers. It has generated 3 hidden layers. In each hidden layer, what you are doing? How many number of nodes are to be there? You are calculating with the help of this factor. So you're using this factor here. You see, you're using this factor. So in order to form the what you say, the number of nodes in that particular layer. So in the first layer you have 10 nodes, in the second layer you have 6 nodes, and the third layer you have 5 nodes, right? What is this after this third layer, what happens? It will get connected to the output layer, right? And that output layer also has 5 nodes. Any doubts here?
No, sir, we can try.
Okay, fine. So then what we can do is next is we are actually able to summarize the model parameters by using the Keras what do you say, with the help of this Keras TensorFlow package. It is possible to create a feed forward artificial neural network, and that is nothing but a model that you have actually built. Upon that model, there is a method called summary. This method, summary method, will provide us for each hidden layer how many parameters are actually uh, present, right? So so this dense you are using dense method to populate your hidden layer with input dimensions, and what you say, the inputs are coming from the previous layer, right? So this is the input size that you have defined. The input size is 100 here, and the number of features that you provide as input to the hidden layer are 100, right? To this you are using activation function called ReLU, right? Now what is the formula? If you see, 256 dense method, if I go to the dense method quickly, what the dense method tell us, right? 1 minute. Control T. So dense in Keras. So dense method in Keras, it has the parameters like this: input kernel, right, dot bias and activation. So the value 16, right? For example, the input shape is 8 and the number of units is 16, then the output shape is 16, right? So this is the input shape as you see in this program. So I think the what is the screen that you are able to see is is the program screen or the window screen? Fine. So we'll go to the program here. So if you see here, we have the input shape to be 256 in the form of the number of uh, dimensions, and the input size is 100. So this is nothing but 256 into 100. We have 25600 plus what is added here, what is added, right? What is the remaining value? The remaining input size, the remaining input shape is added to the parameters. So this input shape is also treated as a parameter in order to find the total number of parameters in that layer, right? So next, when you come next to the, if you are going to the next hidden layer, right? So you have 64, 64 is the shape, and the activation function you are used is ReLU, right? Now what is actually happening? So 64 in terms of number of parameters. Now if you see, it is multiplied with the 256 from the input. So 256 into 64, it will give you some value. To that, 64 is once again added, right? The input shape, right? If you multiply, it is very clear, right? I will multiply simply, you see. So 256 into 64, which give you 16,384. To that, what you are adding is once again the input shape to finalize the number of parameters in that layer, right? So this you are simply adding 64. Now what is the value I got is 16,448 in the calculator. The same values I can see in the number of parameters for that layer. Right, in the second layer, what you have done is the input shape defined is 32, right? And that input shape, what is this input shape coming from, present in the each layer? Nothing but the processed output coming from the previous layer, right? So this processed output is now present as input to this next hidden layer, and that is 32, that is the input shape. And now what happened to this input? What is the output, earlier output, earlier input for this input shape, that is 64. So 64 into 32, now what is the value? 0. 64 into 32, we have 2048. To that, once again you add 32, right? What is the value got? 2080, right? Now in the same lines, you are going to the last hidden layer or the last output layer. This is the output layer. In the output layer, what we are using is softmax function, which throws probabilities, right? Which throws probabilities for the sake of classifying the inputs. So it has 32 into 2, 64, 64, right? 64 plus 2 two nodes in the output layer. So 62, 64 plus 2, 66 parameters. So like this, the number of parameters are calculated at each and every layer, and those are finally added to specify total number of parameters in the generated artificial neural network, right? Now what we do is we quickly go to the next program, that is predictive maintenance, which is your uh, scenario. Now what we are doing is we have developed a feed forward uh, artificial neural network, and that to a specific type of neural network called LSTM. So this LSTM is a long short-term memory network, which, which has the capability to store and what you say, information for two different types of information, like short information as well as long range information in its memory, right? It has three different types of gates: input gate, forget gate, and output gate. So all these three gates with memory, they will communicate among themselves to show up the final classification information. So here what you can do is, for this is the first time I am showing you in this in this collab, how do you change the runtime, right? So here what you are doing is, you can change the runtime by simply clicking on the runtime menu and clicking on submenu change runtime type. So in this change runtime type, now I am selecting the hardware accelerator from CPU to T4 GPU, right? I can use GPU hardware accelerator to to see the outputs in the to process the run the program in the faster manner, right? Now what I will do is, I will simply run these cells. uh, ANN for predictive maintenance for industrial machines is the scenario. Now that we are seeing in, we will run this, right? Once this T4 is allocated, now this thing will be downloaded. Right now, I will run this. You please concentrate on this particular area, right? How fast you will see the output, right? You see the number of epochs running in the faster manner. You see, within no time we have reached the 10 epochs, right? And what the LSTM model has predicted for the new data, for the new incoming data, it has predicted that the machine failure is likely with the 48.67% accuracy. It has predicted that the machine failure is likely. So this is the condition that you have written. If prediction value is greater than 0.5, then you say it is likely or it is operating normally, right? So what are the attributes that you have taken in here? The sensor readings, real-time sensor readings you have taken, and you are simply uh, uh, saying the output layer as what is called as the failure normal condition of the industrial machine, right? Now the loss that we are using is MSC. So MSC is for regression. So binary underscore cross entropy is the is the thing that you need to use here, cross entropy. So simply we will run this for the sake of classification task. The last function should be binary cross entropy. So I am using this and I am seeing the output here. You see. So now you see how the change has occurred, how the accuracy has been improved. So as this is a classification task, right? As I am using the last function to be the cross entropy loss function, and the optimizer that I have used is Adam optimizer. So these two things, what they does is they will reduce the overfitting in the model, right, and reduce this loss to a greater extent. As you see, the validation accuracy and the validation loss, it has been what you say, it has slowly validation loss has been increased. So as the validation loss is increased, your test accuracy has got decreased. If this has value is if this value is decreasing, so that the validation accuracy will now increase. As you have observed carefully, this validation accuracy is stable, and so sometimes it is slightly getting reduced, right? Because of the combinations of loss function and optimizers, you will see this kind of results. And now because of this optimizer and the loss function, you are seeing the machine is likely to continue operating normally for this particular prediction condition, right? And this is the layered view of this LSTM model. So it is a small model, so for that reason you are seeing the output in this fashion, right? So with this we come to the end of this session, right? If the participants have got any doubts, you can unmute yourself for the next 2 minutes, or else we will simply complete this session, right? participants, you can unmute yourself or you can type it in the chat box to uh, uh, ask your questions. Any doubts, you can unmute yourself. Yes, participants, may I know if you have any doubts, you can raise the question.
No, they are replying in chat box, sir.
Okay, they are replying in the chat box. I haven't seen. Okay. Okay. So if that is the case, then we can simply close this last session. So
Okay, sir.
thank you, participants, for your engaging 6 days to say representation for this workshop. And I also thank HOD Mechanical Engineering for giving me this opportunity to uh, provide you with the concept of machine learning for the mechanical engineering scenarios. And I also thank the faculty of mechanical engineering department who supported me all the way through here to understand the scenarios of mechanical engineering. And I also thank from the bottom of my heart from the my department, computer science and engineering department, to what you said, to allow me to do this FDP in this smooth manner. And I also especially thank the uh, vice principal sir, and dean academics madam for supporting me through this entire 6 days FDP. So thank you. And I also specially I need to thank the coordinators who are supporting me all the way through 6 days, and making my FDP to deal with FDP comfortably. Thank you.
Thank you very much, sir, for your valuable speech and for the session.
Thank you, sir.
Thank you, sir. Thank you very much, sir.
Okay, participants, we are going to start the valedictory session of the FDP.
అది మన వేరియేషన్ సార్ ఏం చెప్పారంటే 60 మందిలో 20 మందికి
In few minutes, we are going to start the valedictory session of the FDP, Amma. Good afternoon, sir. Shiva Reddy, sir. Good afternoon.
Good afternoon.
Good afternoon, sir.
గుడ్ ఆఫ్టర్నూన్ సార్.
Now I request Dr. M. Venkatramana Garu, head of the mechanical department, to speak some words about FDP.
Respected Vice Principal sir, Professor Shiva Reddy garu, the coordinator Mr. Srinivas Reddy, and the lead faculty of the FDP, Dr. Teja Santosh, and my dear participants. Good afternoon, one and all. Really a marathon faculty development program for the last 6 days. Continuously it is there. And for this program, totally, there is a huge response. Around 400 people have registered. Of course, we are contemplating that how many of people will continuously attend. We got our own doubts, but even then, I really appreciate the participants on any day. Till yesterday, I have seen the average number of participants is 200, bleeding around plus or minus 10. So really, it's a good participation. But today, I could see only 100 and 110 or 115 the participants. Of course, This faculty development program on machine learning is mainly designed for orient our mechanical people towards this new cutting edge technologies like machine learning. I really congratulate the coordinators, Mr. Srinivas Reddy and Sai Kiran, for working together along with Dr. Teja Santosh to identify the problems related to mechanical engineering and developing the algorithms for the mechanical engineering problems. And really, I congratulate the coordinators and entire organizing team. They are doing an excellent job for the last 5 days. Exactly everything is doing on time. And of course, how far the participants got benefited, I observed the proceedings. The lecture was very serious, and it seems many people are interacting during the lab session as well as during the theory sessions. So I feel that definitely the faculty have done a good job. And of course, the lead faculty is Dr. Teja Santosh. Along with Dr. Teja Santosh, two professors from NIT Warangal. Today morning, Dr. Kumar. Yesterday, Dr. Vasu has in the last minute they have accepted our request and gave lecture in this particular faculty development program. Here, I got one appeal to all participants. This particular FDP program is not meant for only giving a certificate and just showing it to our whenever the faculty appraisal. That the purpose of this program is not that. Only thing is to enlighten the mechanical people how to take up a research problem or how to take up a problem for a publication in the area of the machine learning. So that is the purpose of this particular program. And another thing is, of course, it is only a beginning, because for mechanical people, all these back propagation, neural network, algorithm, etc., all these is the new terms. In this FDP program, we only get introductory information, and from this we should start go on building up the things. And really at this point I got one point to tell. All our faculty members are open to work with the faculty from the other colleges to go for the joint publication or to go in for a joint project or anything of that sort. So I request the participants, whoever is interested, you be in contact with the our lead faculty and other faculty members. You can plan for a joint publication so that it's a win-win situation for CVR and win situation for the other people also. So, and for the last 5 days, all our what is it? Networking people have done a good job. And provided the necessary Zoom link. Mr. Brahmanand and his team, Zoom link, as well as the CAD/CAM lab in charge, Mr. Venkatesh, for providing his space, for giving a disturb-free environment for providing the lecture. So last but the most important is, I thank the management, chairman sir, principal sir, Dean Madam and Vice Principal Sir, for giving an opportunity to permit us to conduct this program. And most importantly, I'm extremely thankful to Dr. Vani Vatsala, Madam, who is the professor and head of computer science department, who has spared Dr. Teja Santosh for us for the last 5 days continuously for conducting this faculty development program. And I am quite hopeful that these kind of programs will be conducted in time to come. And at this point of time, I got one thing to share with all the participants. The expertise of CVR is many of our faculty members have got expertise in the CNC machining, and they are offering consultancy services to various departments. For in the last 3 years, we could provide a consultancy of around 15 lakhs of rupees, and the publication rate of our faculty members is also quite high. But only thing is, a single person cannot do all these things. So therefore, I appeal all the participants to have a network with our faculty members to go for a joint publications for improving your citations and for improving your competency. So it is my earnest request. That's all, Srinivas Reddy from my side.
Thank you, sir. Thank you, sir. Now I request Professor L.C. Shiva Reddy Garu, Vice Principal, CVR College of Engineering, to speak some words about FDP.
Good afternoon, everyone.
Good afternoon.
Head Department of Mechanical Engineering, and anchor Srinivas Reddy, and Dr. Teja Santosh, who was the lead faculty for this particular FDP. First, let me congratulate the Mechanical Engineering Department for taking the initiative in conducting this particular FDP. One thing, of course, from the beginning or whenever we talk about in the educational institutions, we talk about interdisciplinary approach for many projects, main projects, and then things like that. But in this particular case, they have taken the lead, and then the computer science department has also come up, and then they have looked at what kind of contents can be delivered. So in that sense, I appreciate both the departments' effort in working together. Of course, in CVR, we are doing this interdisciplinary kind of things. Electronics department and mechanical department, similarly to other departments together, the things are being held like this. But one thing what I can say is that the most of the new subjects, most of the emerging technology subjects in terms of artificial intelligence, machine learning, data science, and cyber security. So in all these cases, these are the new things that are emerging now. And then the core departments faculty also, they must also, now that it is the time that it is a high time that they should also learn certain new technologies and apply these technologies to their field. So that is very important, because otherwise mechanical engineering, first industrial revolution, so 200 to 300 years kind of engineering strength they have. But the same thing now, the new technologies, they should be able to apply their particular field. So that is where this particular FDP comes into picture. Because a fellow like me who graduated or who got my computer science degree sometime in the 80s, then obviously the new things that are there, the say neural networks or artificial intelligence, machine learning, deep learning, and then all kinds of things, for me also they are new. So if obviously for the core branches, they are much more, they are definitely not, they will be first time they will be hearing the terms and the terminology. So one thing is, it is a beginning, and then we should, as a teacher, we are supposed to be continuously learning. Some things which we have learned, unlearn, and something new things we are supposed to learn. So I think this is a good beginning, and I hope all the participants have gained sufficient interest in pursue their areas of research in including or applying machine learning to their research problems. So I think that I thank on this occasion Dr. Teja Santosh, who has been the lead faculty, and then hope that he has created enough interest in all the participants who have attended this particular workshop. So I thank the organizers for giving me this opportunity to speak to in this particular function. Thank you, one and all.
Thank you, sir.
Thank you very much, sir. Thank you very much, sir. Now I request Dr. A. Vani Vasalya, Department, CSE Department, Head of the Department, to speak some words about FDP.
Vani Vatsala madam, could you join? It seems madam has got a meeting, she told. I don't know.
Okay, actually madam is there in the list.
There, huh? Okay, anyway, carry on. Yeah.
Okay. Now I request Now I request participants to unmute themselves and give their valuable feedback. Now I request participants to unmute themselves and give their valuable feedback about FDP.
Anybody, any faculty, any participant.
Participants, you can unmute yourself.
Hello.
Sir, good afternoon.
Good afternoon, sir.
Good afternoon,
Hello.
sir.
Good afternoon, sir.
I am Dr. Lingesh from Bangalore Institute of Technology, Bangalore.
Yeah, sir.
It is a very wonderful session, sir. Actually, we never thought that the machine learning can be applied to mechanical domain.
Yeah, yeah.
By attending this FTP, I learnt a lot that how this particular, machine learning technology can be adapted for our domain. I am looking forward to attend the few more activities conducted by your institution, sir. So thank you
Yeah.
very much to speak few words about this FTP. I thank all the organizers for their effort to coming out with this wonderful FTP program, sir. Thank you.
Thank you, sir.
Thank you, sir. Thank you.
Participants, please unmute yourself.
Yes, sir. Yes, sir. Thanks a lot, sir.
Hello.
Hello. Sir.
Yeah, I am Dr. Rachaya Rikirimat from Pune. So this session was interesting, sir. We had very fruitful sessions, and especially your collab sessions and the lab session, they were interesting because as a mechanical engineer is concerned, we all are practical people, so we enjoyed those sessions, sir, though I attended online. And especially in Pune, we are having the AIML as a one of the honor subject or maybe one of the elective subject. So hopefully in your side also in mechanical it should be there. So definitely there is no any difference as such the applications are concerned. So really your people were coordinated and organized very well, sir. Thank you. Thanks a lot for giving the time to give feedback.
Thank you very much, sir.
Thank you, sir. Thank you.
Srinivas Reddy, are you sending feedback link?
Yes, sir. Already overall feedback link has
Feedback
been
link,
shared.
okay.
Yes, sir. Already.
Good afternoon, sir.
Good afternoon.
I'm Dr. Ishrita from Kamcha College of Engineering and Technology. Like these sessions were very well organized because it just not focused on in like machine learning or this thing, but the thing is with the content there was much focus about the practical sessions and very well like the sir was I'm very thankful to Dr. D Teja Santosh sir
Thank you,
because
ma'am.
he has been constantly working. It's not such an easy task like take the session in the morning based on the session how to execute and with the applications on mechanical engineering how to discuss each and every practical aspect. It was very well organized and we were not just that you have had your faculty but you have tried to include the speakers from NIT Warangal that also each and every session though we have other things wanted to devote somewhere else but we could not because the content was very catchy and helpful and useful from the research aspect or it can be from the paper publications. Definitely we'll look forward for a collaborative work and collaborative projects, sir. Thank you so much. Thank you so much for organizing such a workshop, sir. Thank you to the entire team of CVR. Thank you.
Thanks,
Thank you,
madam.
madam.
Thanks, madam.
Thank you.
Hello sir, I am Vikas Kumar from Ajay Kumar Garg Engineering College, Ghaziabad. It is in a Delhi NCR region.
Yes.
Sir, I have attended all 6 days FDP and from last 16 years I am in academia. I can only say this is one of the best FDP I have attended in online mode.
Oh, thanks,
So
sir.
Thank you. Thank you, sir.
for any FDP, one thing we should always carry in our mind should be like within time limit, and you have your team excellently like control these time limits. That was the best part. Whatever thing you have declared in the very beginning, from this to this, we have going to organize this session, first half session, second half session. So all were organized very well. Definitely, it's team effort, sir. Your team did very good job. But my special thanks to Teja, sir, because the energy that he has shown throughout the session was extremely like very, very good. So thank you, Teja, sir, and you inspired a lot because updating ourselves is a need of today's, because we have to change. With this change, then only we can survive in this world. So it was very inspiring, FDP. So
Thank you, sir.
thank you
Thank you.
all. Thank you, sir.
Thank you.
One last participant, if anybody is there. If anybody is there, one last participant. Otherwise, we can close.
Good afternoon, all. Myself Anuj. I'm from industry.
Yes, sir. Which industry, sir?
I'm from power industry.
Yes, sir. Yes, sir.
Just I was interested by the program, and just being a FD, I was much interested in learning machine learning programming. So I'm basically from power industry. So my area of industry is like turbines and all. So I think you have done much more. You given much more importance to the areas such as manufacturing. I would like to have some sessions in future if you good for something like predict of machine learning for turbines, machine for heat transfer, where we take large time for simulating the conditions and all. So if anything related to that would be great. And anyway, all the sessions were good, and I didn't complete watch all the session because I am working too. But I was very much interested, and the way which he explained, Mr. Faculty, Dr. Teja Santosh, was good, very good, excellent. I mean, from a mechanical point of view, we are the way which we delivered has deeply percolated this data into our body, into our mind. So in future, I would like to have few sessions regarding that heat transfer or something like fluid mechanics and all. Anyway, it's a very good session. Thank you. All the best for you.
Thank you, sir.
Thank you, sir. Thank you.
Srinivas Reddy.
Sir.
Shall we close?
Venkatramana sir, just 1 minute. Can I say?
Madam, I am inviting you, madam.
Please.
Now I request Dr. A. Vani Vasalya, head of the head of the CSC department, to speak some words about FDP.
Thank you, sir. So good afternoon, Dr. Venkatramana sir and all participants. I'm very happy to see that such an online workshop on machine learning applications for mechanical engineers has become such a huge success. I should congratulate mechanical department for identifying the need of the hour and then conducting such a session on machine learning for mechanical engineers. So I am also envying them because we could not tap our own talent. We never conducted any FDP with Teja Santosh sir, but they have identified rightly and they have conducted such a session. And also I am hearing the feedback from so many participants that the workshop or this FDP is really useful for them. So I'm very happy to know that this has been a very fruitful session, and I congratulate mechanical department and all the organizers for conducting these online sessions successfully. And I wish all the participants will take maximum benefit, maximum take back from this FDP and continue working in this area. Thank you, sir.
Thanks,
Thank you
madam.
very much,
Thanks
madam.
for
Thank you, madam.
sharing Teja Santosh. Yeah. Lastly, Srinivas Reddy, I am concluding.
Okay,
all
sir.
the participants, I thank all the participants because the participants are the main driving force for conducting any faculty development program. Really, we are enthused with the number of participants that they have registered, and with that, our interest also has gone up like anything. And I should be thankful to all the participants for encouraging us in this way. In time to come, we'll see for such kind of joint programs in time to come. Thank you all. Wish you all the best. Thank you.
Thank you, sir.
Thank you.
Thank you, madam.
Yeah, close change. Was ready.
Okay, sir. Okay.
Finally, I would like to thank all the participants, the HOD of CSC and HOD of Mechanical Engineering, and all the faculty of Mechanical Engineering department, particularly Neeraj Kumar sir, and the other faculty. If I am sorry if I don't take their names, but still I am very much indebted to Mechanical Engineering department faculty who have supported me all the way through this conducting for this workshop, uh, by making me understand the scenarios, mechanical engineering scenarios. And I thank the FDP coordinators for supporting me all the way through the 6 days of this workshop. FDP, thank you.